In this lesson we're going to look at various situations of imaging using a thin converging lens, which we introduced in the previous lesson. So let's just remind ourselves of some of the parameters here. We've got the principal axis, which passes through the center of the lens, and then we've got the principal focus here, which we'll call F1 and F2, and this is the principal plane which passes through the center of the lens in the vertical direction, and the distance from the principal plane to the principal focus is the focal length, and likewise the distance from the principal plane to the other principal focus F2 is the same focal length. So these distances are exactly the same, F2 to the principal plane and F1 to the principal plane. Okay, so we're looking at imaging in this lesson. So we have an object which we'll call O, which is this star on the little pole here, and we're going to see how we can form an image using this lens. Okay, so the first thing we'll do is we'll trace a ray from the top of the object to the lens, which is parallel to the principal axis. Okay, and we trace that ray right up to the principal plane. Now, you may well be asked to do something like this in your GCSE exams, and in most of the questions that I've observed, they always include the principal plane here in the center of the lens. So this ray should always go up to that principal plane, not to the surface of the lens, but to the principal plane in the middle. And then from there, the ray will then pass through the principal focus of the lens F1. Now, we then draw another ray from the top of the object, which will pass through the center of the lens. So every single ray that comes from the object that passes through the center of this thin lens will never be deviated. Okay, it will not be refracted or bent at all, assuming that we have a thin lens. Okay, so that ray will go straight through the center of the lens without being deviated. Now I should have drew this ray through a bit further, which I'm going to do now, and you'll see why in a minute, just so that we can see the intersection between the two rays. Okay, and where those two rays intersect, that defines the position of the image. Okay, and we can position the image there. So first of all, we'll notice two things about the image: that A, the image is inverted, and B, that it is a real image. Now what we mean by that is you can form this image on a screen. So if I take a screen or a piece of paper, for example, I move this towards the lens, then when it hits this position here, the image of the pole and the star will form on the piece of paper. It is a real image. Now just a few more definitions here, which I won't go through in the next lesson, but just so that we're clear about this. We can talk about the object distance, which is the distance from the principal plane to the object. And we can also talk about the image distance, which is the distance from the principal plane to the image. Now that in this particular case, you'll notice that the size of the image is the same as the size of the object, and actually that the image distance is the same as the object distance. Okay, now this only happens when the distance from the object to the principal plane is exactly 2 times the focal length of the lens. Okay, so this is really why all this is called geometrical optics. It's all about geometry, and you don't really need to worry too much about this for your GCSE, but what we're saying is that the distance, that's the focal length of the lens, and what we're saying is that the distance of the object to the principal plane of the lens is exactly 2 times the focal length. Okay, when that happens, then the height of the image is equal to the height of the object, and the distance from the principal plane of the lens to the image is the same as that to the object. Now it's quite common in the IGCSE or GCSE questions that you're asked to draw the path of a third ray through a lens like this, and what I'd like to say is this: that once you've defined the position of the image, which we have done here, then every single ray that leaves this point here on the object will always finish at the same point in the image, assuming that these rays are being bent by a perfect thin lens, which is always going to be the case in the exam questions. So it doesn't actually matter which path we choose. it will always end up at this point here in the image. But one thing that you're quite often asked to do is trace a third ray, leaving the object and passing through the second principal focus f2. Okay, like that. So you trace that through, and in this particular case the ray will always come out parallel to the principal axis because of the geometry of the situation. Okay, like that. But if you're being asked to draw a third ray, it doesn't really matter which path you choose. You can choose that one through f2, or you can choose this one up to the principal plane and from there to the corresponding point on the image, or via this path, for example. So in the next lesson, what we'll do is we'll have a look at what happens to the image when we move the object away from the lens and when we move it towards the lens.